As already we have seen that gyroscope is the instrument in which disk is rotating, and the axis on which that disk is mounted, that is also going to spin about a vertical axis or about any axis. And we have seen that the gyroscopic effect, how the gyroscopic couple is generated. My previous video lecture has shown that practically how that bicycle wheel remains straight without application of any couple or force on that wheel. Now we are going to see that which are the uses in our daily life that are encountered by means of this gyroscopic couple, or on which the gyroscopic couple is acting. We are going to see first of all the gyroscopic effect on aeroplane. Then we are going to see gyroscopic effect on ship, and we are going to see gyroscopic effect on automobile, that is four wheelers, as well as on the two wheelers, and how that gyroscopic couple is used to have the stability of that vehicles, as you can take aeroplane, as you can take ship or automobile or two wheeler. Out of that, now we are going to see the gyroscopic effect on aeroplane. Now here we can see that aeroplane, and in that aeroplane, as we know that turbo engines are used, which are rotating with impeller which is mounted on with that engine. Now in this case, the action is taking place as the turbo jet engine is going to rotate a huge amount of inertia of that jet engine, and if that aeroplane is taking turn, that is nothing but the disc which we can consider as a aeroplane engine and its propeller. That disc is rotating, and as the aeroplane is taking turn, that disc is going to spin. Now the plane in which the disc is rotating and the plane in which that axis is going to rotate are mutually perpendicular to each other, that we can see here. This lower one diagram shows how that gyroscopic couple or how that gyroscopic action is taking place in the aeroplane. In the first figure, you can see the direction of viewing when the rotor is going to rotate, as well as while we are taking turn to the left or to the right, how that gyroscopic couple will act. The next one diagram has shown that the axis, three mutually perpendicular axis, the axis of rotation, axis of spin, and the effect of that gyroscopic couple. As well as lower one diagram has shown three mutually perpendicular planes in which the action is taking place. Now we'll see next slide. Sorry. This slide shows that how the gyroscopic couple will act on the aeroplane. Now aeroplane, while it is taking left turn, what will happen to the gyroscopic couple? Due to gyroscopic couple, there is chance that the nose of that aeroplane will get lifted, whereas it is taking right turn, then that nose may get down. It is depend upon in which direction that propeller is going to rotate. When you are going to observe it from rear side of that aeroplane or from the front side of that aeroplane. I have explained how to measure that, or how to calculate that gyroscopic couple, and how to judge the effect of that gyroscopic couple on aeroplane. Now the lower one table is going to show that how that gyroscopic effect will be there on aeroplane. First, while we are taking turn, then if we are going to see that rotor and whole that engine rotating from the rear side of that aeroplane, while aeroplane is taking left turn, and if the rotor is rotating clockwise, then nose will get rise and tail will get dip automatically. The reverse way, if aeroplane is taking right turn, and same way the rotor is rotating in clockwise only, then nose will get dip and tail will get rise. Whereas if the rotor is rotating in anti-clockwise direction, when you are going to see from the rear side or rear end of that aeroplane, and if that aeroplane is taking left turn, then nose will get dip and tail will get rise. Whereas if the aeroplane is taking right turn and if the rotor is rotating in anti-clockwise direction, then the nose will get rise and tail will get dip. Now these are the four conditions as far as the aeroplane is considered, and there are these four possibilities only. That is, that rotor will rotate either in clockwise direction or in anti-clockwise direction when you are going to see it from rear side, and that aeroplane will take either right turn or left turn. So depending upon that, effect of that gyroscopic couple will be there on that aeroplane. And while we are going to fly with that aeroplane, that all these effects will be there, and that pilot should know, pilot should aware about all these effects. Next slide, we are going to see actual problem based on this effect on aeroplane. Now in this slide, you can see one problem is given, that an aeroplane makes a complete half circle of 50-meter radius towards left when flying at 200 km per hour. The rotary engine and the propeller of the plane has mass of 400 kg and radius of gyration is 0.3 meter. The engine rotates at 2400 rpm clockwise when viewed from the rear. Find the gyroscopic couple and its effect. Now while we are going to get the solution, we know that the radius of rotation r, that is the radius at which the plane is taking turn, that radius is nothing but the radius by means of which the disc which we are going to consider as a aeroplane engine and propeller mass which is rotating, that disc is going to take turn. So we can calculate speed at which the aeroplane is taking that turn, that is 200 km per hour. We can calculate it as a 55.6 meter per second. Now mass of rotating parts, whole rotating parts are considered together, and that is considered as a single disc, that is m, is equal to 400 kg, and radius of gyration is 0.3. Now we have to, first of all, we have to calculate the omega by which that disc is rotating, that is engine is rotating. Engine is rotating at 2400 rpm, hence omega can be calculated as 2 pi n divided by 60. That will be 2 pi into 2400 divided by 60, and that will come as a 251 radian per second. Now we can see that we have to calculate mass moment of inertia of that disc or that engine whole we are going to consider, that is I is equal to mk square, that is 400 into 0.3 bracket square, that is 36 kg per meter not per 36 kg meter square. That velocity of plane v can be calculated. We know that v is equal to r into omega, where this omega now we are going to consider is the omega p, that is the angular velocity of precision, the velocity by means of which the disc is taking turn, that is axis of rotation is rotating along the vertical axis. Now this velocity can be calculated as v is equal to r into omega p, where omega p is angular velocity of precision. Now omega p is calculated as v by r. Now we have calculated as a 55.6, divided by r is 50, and that comes as a 1.11 radian per second. Now we know that gyroscopic couple is equal to c suffix cc, that is gyroscopic couple, is equal to I, mass moment of inertia of disc, into omega, that is the angular velocity by means of which disk is rotating, and omega p, that is the angular velocity of precision, that is equal to 36 multiplied by 2251 into 1.11, and that comes as a 10,046 Newton meter. And this is what we can say the total couple which is acting on that aeroplane. And effect of that couple is that we have to calculate, that we have to find what will happen to the aeroplane, whether the nose will get up or nose will get down. Now effect is judged as in our case that aeroplane is taking left turn and engine is rotating in clockwise direction when viewed from the rear. Hence, what will happen, that nose of that aeroplane will get rise and automatically that tail will get dip. That actually we have to write there that effect of that gyroscopic couple on that aeroplane.